Living Soil Tree Farm, and he can tell you more about himself and a lot about composting. I've seen a draft, and even though I've been composting for a long time, there were still some things that were new to me. So I hope you'll enjoy that.
Sweet. All right, well, friends, my name is Nick. My organization is Living Soil Tree Farm. I'm primarily a plant nursery, but we do also some composting services, and we've got, chickens and a handful of other small farm operations going on. We are offering, we're starting in June, we're going to start offering a curbside food waste collection service here in Blacksburg and also to Christiansburg residents. If you're not interested in composting yourself, we will take it to Roanoke to a facility over there that's permitted and approved to process the waste. So today, I want to leave you with some more practical information if you guys do want to do your own composting. So we're going to jump right into that. But before I start, is anyone in the back especially having trouble hearing me at all? Is the volume's pretty good? Okay. All right. I'll try to talk a little bit louder. And if you're having trouble hearing me, just raise your hand and I'll know to kind of put it up. And we will have time for questions at the end here. So all right. So what's going to happen to your food waste? There's basically two things that can happen. I think probably everyone in this room is familiar with that. It's either going to get thrown in the trash or it's going to be composted. There's a lot of nuances in terms of how the trash can be handled and how the food waste can be composted. But at the end of the day, that's kind of the juxtaposition we're making is we're wasting these nutrients by throwing them into the landfill. The landfill is going to be a low oxygen environment, so there's going to be a high release of greenhouse gases, a mix of methane, nitrous oxide, carbon dioxide, and others. And as I said, so those nutrients are lost. When you're composting, there's different ways to compost, which we'll talk about, but primarily we're trying to maintain the compost as an aerobic system that's going to diminish the amount of greenhouse gases that are released, but perhaps more importantly, we're saving those nutrients and putting them back onto local farms. And we are going to move pretty fast through these first handful of slides here. I want to leave you guys with a lot of the how-to information at the end, but I think it's important to kind of set the table with some of the details before we dive into that. So how much food waste are we actually wasting? There's data from various organizations out there, but roughly 50% of household trash in this country is compostable. Of that, about 20 to 21% is food waste. The rest of it is cardboard, yard waste, all that sort of stuff. So we're talking about a lot of material, a lot of wasted opportunity, and a lot of emissions into the atmosphere. And one thing that I have learned communicating to people about compost throughout my life is that as important as the emissions are, a lot of the other downstream benefits of compost tend to get people more excited about the process. And so I think it's important to touch on that a little bit here. When we apply compost to the soil, all sorts of things happen. So for one, we can filter a lot of pollutants out of our stormwater. This is a huge issue, especially in our urban and suburban areas. And as these storms get more frequent and more severe, we're losing a lot of stuff downstream. Compost has a tremendous ability to filter out some of those pollutants. And it's compost in combination with plant roots and all this sort of stuff. But basically what we're talking about is improving soil. And that can be in your backyard where you have landscape plantings. That can be on a farm, in a local park or a forest. Anywhere that we're applying compost, we're going to change and improve the physical structure of the soil by adding pore space and organic matter. We can dramatically increase how much water we can hold in the soil, which is important for crops. If we can go longer without rain, without having significant stress on the crops, if we're holding more water in the soil. So this is of dramatic importance. We all know, I assume, that there's a bit of a fertilizer crisis going on right now due to ongoing conflicts around the world. And so compost is one way that we can increase our farm's resilience by not having to rely so heavily on nutrients coming from these chemically based fossil fuel-based fertilizers. We can get a lot of our nutritional needs from applying the compost to the soil. So I think it's important to keep all that in mind when you're making compost and when you're talking to people about compost, because this is exciting stuff. It's kind of scary and sad to talk about emissions. It's important to talk about emissions, but I think some people just kind of shut down when they hear that story, whereas this is all exciting stuff to talk about. We can also talk about, when we're making this comparison with greenhouse gases, we're not just lowering the emissions of our food waste, we're also going to help the soil where we apply the compost to be able to capture more carbon downstream. So this is from boosting plant health, having more plant biomass, but also boosting microbial mass in the soil. and increasing organic matter in the soil. All of these methods, or all of this, is capturing carbon. So it's not just a simple, how much greenhouse gas are we saving by keeping this stuff out of the landfill? It's also, like I said, all these downstream consequences are important to consider. This is a bit of a weird one. Composting does create more jobs, which you might think, the trajectory of civilization, we want to make things more efficient and have less labor involved. But I will say right now, with the way the economy is going and job loss to various things like AI, it can be a benefit to local economies to have more jobs, especially jobs that are paying a living wage and that are meaningful work. So I think composting can really be a big boom for local economies. The meat and potatoes of this is going to be how to compost at home. And there's a lot to cover. Compost can be kind of complicated. I'm going to do my best to demystify it here. A lot of the questions that I get are around what can be composted and really anything that was recently alive. And you've probably heard all sorts of things like meat can't be composted or eggshells. All these things can be composted, but you need to know how that material behaves in your pile before you get into it. And so that's what we're going to try to talk about today. Compost, all of the different inputs and ingredients we're using, we're going to typically classify them by the level of carbon and nitrogen that they have. This can be correlated to greens versus browns. You may have heard this discussion before, the browns being the high carbon, the green being the high nitrogen. And when we talk about nitrogen, really what we're talking about is protein, amino acid, and fuel for the microbes. What's happening when you're composting anything is microbes are eating that material and breaking it down into base parts. Those microbes grow, but just like us, in order to grow, they need proteins and amino acids to build all of their cells. And so when we're classifying ingredients that have high nitrogen, that's what we're mostly concerned with, is how much microbial growth will that input fuel. As we mentioned at the beginning, so we are trying to keep this aerobic, or we want to keep it oxygenated when we're doing our backyard composting. And the way to think about this practically is smells. If you have a bad smell coming off your compost pile, there's probably some greenhouse gas being emitted. You probably are moving to a lower oxygen situation. And so you can really use your nose to kind of guide in a backyard scale. If we're talking about industrial scale, there's other ways to measure what's going on. But for backyard usage, I like to recommend that people really use their nose. And we'll talk more about mixing piles later on. But one thing to keep in mind, the better the texture is in your pile, the better aeration you're going to have. And so having a good structure in your pile, lots of pore space for oxygen to get in, can be very important. When we're classifying inputs, I want to give some examples of some of the different materials. So for our carbons or our browns, a lot of these come from trees. They don't have to come from trees, but a lot of the most available browns, carbon material you'll get are like wood chips, fall leaves, sawdust, shredded paper and cardboard. These are also tree products. But dry hay and straw can also work. Basically, if it's brown and dry, it is probably a brown material, a carbon-rich material, with the exception of dried manure is not brown. It is brown in color, but it's not going to be classified as high carbon because it's got a lot of nitrogen in it. High nitrogen inputs, there's a lot of variation here. So a lot of the talk today is around food waste. Food waste is a high nitrogen input, but your food waste can look very different from day to day, from household to household. Anything like vegetable waste, leftovers, nuts, eggshells, as well as animal products like manure, meat, bones, things that are coming out of your garden like grass clippings, anything that is physically green is usually going to be a high nitrogen material. And we're going to talk about a few different methods to compost. In the backyard, the easiest way is what's called static compost. And for that, I like a ratio of roughly 70% carbon to 30% nitrogen. If we're doing a different method like hot compost, we might tweak that ratio, and we're going to talk about more of this in a few minutes. But just to give you an idea, you're going to need a lot more browns than you are greens when you're making your pile. I have found that wood chips really are the best for texture and aeration. Depending on where you are, wood chips can be hard to source. So this is not to say that you can't compost without wood chips, but I consider wood chips kind of a premium, I don't know, product is the right word, but material for making compost. Before we get into actual composting methods, we're still at the beginning here. We're trying to just classify what materials do I have? I have food waste. I want to compost it. What browns do I have? Do you have other sources of greens that you want to deal with, like yard clippings? You need to be thinking about the pathogen load of your material. Because one of the goals of composting is not simply to just break down the material and make it useful. We also want to deal with any pathogen load that might be in those inputs. And especially some of our higher pathogen risks, like if you're composting meat, eggs, animal byproducts, really, really spoiled food waste. If you have some leftovers that were in the back of the fridge, you forgot about them for a long time. And, these sorts of things can have high levels of human and plant pathogens. And compost systems can be designed to deal with that, but we need to be aware that those pathogens are in the system and thinking about that. Kind of at the medium pathogen risk is going to be yard waste, garden waste. There might be some pathogens in there, but it's not a super dangerous material to handle. And most of our carbon-based inputs don't really have a whole lot of pathogen load in them. So it's important after you classify your materials, I think, to consider your goals. Some of you might come at this from a perspective of, I have food waste. I don't want it going to the landfill. I don't really care. I don't have a garden. I don't care about making an input for my garden. I just want to deal with the waste in a responsible way and get it broken down. So you might not care as much about the pathogens. You're just going to spread it perhaps on your landscape plants, somewhere that you're not growing food. Someone else might say, I do want to process my food waste, but I also have a garden and I would like to have a really nice, high quality input to go into my garden. And so these are things to think about as you're setting up your system. There's a lot of different ways to approach composting. I think for today, I'm going to lump it into mostly three categories, which is static compost, or you call it lazy compost. And I don't think there's any negative connotation to lazy here. I think it's an excellent way to go. Worm compost is my personal favorite. I think it makes one of the highest quality ingredients for a garden. And hot compost, which is what most people are familiar with, but is actually, in my experience, very challenging, especially on a small backyard scale. So I will try to walk through each of these, depending on what direction you want to go, but just know that thermophilic compost, hot compost is challenging. The other thing is that at scale, a lot of these do get easier. So hot compost especially gets easier at scale because the larger your pile is, the more thermal mass you have. And so it heats up easier, it loses heat slower. When you're in a backyard scale, this is challenging. And I do want to make a note on anaerobic digestion. This is typically something you see only at scale. Anaerobic digestion is somewhat different from your other composting processes because it is fully contained, usually by steel in some sort of apparatus. And the reason it's contained is it's a low oxygen composting method, and they're capturing the gas to be burned as fuel, as opposed to trying to have an aerobic process that emits lower amounts of gas. At a large scale, anaerobic digestion is certainly viable, and biofuels are a good thing to have. But at a small scale, you need significant infrastructure. And there are examples in other parts of the world of small scale, kind of more, maybe not quite backyard, but community scale anaerobic digesters. This is typically used, from what I've seen, for human manure, processing human waste, not as much for food waste stuff. But if you're interested, you can certainly look into that. When we're dealing with our pathogens, there's a couple different ways that we can go. Basically, each of these composting methods that I outlined has a different method for dealing with the pathogens. One of them is heat. And you can think about this like cooking. If you cook chicken, if you get the internal temperature to 165, you're safe. It can be 165 for 2 seconds and you know that you're safe. If you cook it to like 159 for like 10 minutes, you might also be safe. So heat, depending on the heat and time, can kill the pathogens. And you can look up, there's charts online. You can look up, 131 for 3 days. If it's 150, it'll be shorter, stuff like that. Long spans of time can also kill pathogens. And I think it's important to mention here, we're not talking about getting to know pathogens. We're not in a surgical environment. What we're talking about here is getting the pathogen population in our compost to a safe level to where it could be put in the garden. And scientific studies have looked into this and kind of established what is a safe level, because you're never going to have no pathogens in the soil. They are out there. That's why plants and humans have immune systems. But so heat, long periods of time, the way that works is primarily through competition and lack of food sources. So a lot of these pathogens, you start the compost pile, they're in there, they're eating the food waste. Over time, they use up that food resource. And between the diminishing amount of food and competition from other microbes coming in from the soil, their populations just kind of decline over time until they get to a safe level. And then lastly, worms, which is a little bit more of a mystery how this works. My understanding with worms is that most human and plant pathogens cannot survive a trip through the gut of a worm. For whatever reason, the selection that happens inside of their gut is just very heavily skewed towards beneficial organisms for humans and plants. It's not 100%. Like I said, there's going to be some pathogens kind of in all this stuff, but worms are really good at cleaning up toxic material from a pathogen perspective. And so, depending on which method you choose, it's important to really learn what your benchmarks are. So with static compost, usually you're going to want to wait about a year. And that's a rough approximation because rates of decomposition vary in different parts of the world, different climates, different times of year, the different types of material that you might have. So 1 year is usually a safe number of, or safe time. But depending on, if you say you move in a couple of years and all of a sudden you're up in a much colder climate that has a longer winter, a colder winter, shorter growing season, that means decomposition is going to slow down. You move further south and there's no winter, things are going to speed up. So that 1 year is a little bit ambiguous, but that's typically like a safe recommendation for static. Static compost can be done with aeration. It's kind of a hybrid, and you see this more often at larger scale, but you can set up a backyard system like this where the static compost is still not static. We're kind of jumping around here a little bit, but static just means we're not turning it. We're not moving the pile. It's kind of like we mix it up and we just let it sit. And if you don't want it to take a year, but you still want to do static, you can set up aeration under the pile. Basically, you're putting perforated pipes underground beneath the pile. You hook up a fan to them. That way you're pumping air in. And you're going to now monitor the temperature for the first period of time. And if you can get that temperature after you mix the pile up to 131 to 170, anywhere from 3 to 15 days, depending on your temperature, that will deal with a lot of the pathogens. You then still need to let that static compost cure. And so basically, we can talk about this more in the question and answer part if someone wants to go this route, but this is just an option for not having to turn the compost, but maybe instead of waiting a year, you can get it down to 4 or 5 months. If your interest is getting the compost ready to go sooner. Hot compost is definitely the fastest way to get compost. It is, as I said, also the most complicated. You have to be in that temperature range for 15 days. The problem is that in that period of time, you have to flip the pile 5 times. And you need to get back up to that temperature and maintain it after each flip. And the flip is primarily because only the center of that compost pile is going to get to that temperature. The outside of the pile is never going to get to 131 degrees. It would have to be really, really hot outside. It'd be very bad if the outside was right. So we have to cycle all the material through that hot center. That's the primary function of the turning of the compost is for that reason. And when you turn it, you're adding air. So you're going to cool things down, and it can be hard to get, like I said, back up to temperature. But that's the method for dealing with pathogens in hot compost. And worm compost is a little bit trickier to describe the length of time because a worm system, there's an initial period of getting your worm bin started, getting your population up and running. From the time that you start a bin to the time that you first collect compost, you're probably looking at 3 to 4 months. These are all rough, it depends on how you're doing things. But once you get it up and running, however, you can be harvesting small amounts of worm compost every few weeks from your worm system. So, and you can scale worms up if you really want to have a lot of worm compost. You need a lot of waste, but you could certainly make a lot of worm compost in a small area in your backyard. But I think most people are really going to be dealing with worms like a small bin, a little bucket in the corner of the yard or in the kitchen, something like that. So before we go into, I want to go step by step. If I'm going to make a hot pile, this is what I would do. If I'm going to make a static pile, this is what I would do. Before we get into that, I do want to talk about the shape containing your pile. I get a lot of questions about this from people, especially with small spaces. You certainly can just take your material and pile it on the ground like a pyramid. There's nothing wrong with doing that. It doesn't look the best to some people. It's not really well contained. And I find weeds are easily able to grow up the sides of a pile like that, especially our vining plant friends. They really take to that well, but it can be done. What I prefer is to use pallets to make little bays. I like just getting 3 pallets, wire them together, or you can screw them together with screws. Set up a couple little bays of 3 pallets. That way you've got space to start the pile here. And then when you need more space, you have it set up. You can also make fence rings, kind of the same way that you would make a fence ring to protect a tree from deer browse. You can get chicken wire, hardware cloth, welded wire fence, make a fence ring, whatever size that you want. And for worms, I typically recommend any sorts of buckets, bins, Tupperware, that sort of thing. So you get to pick your composting method and your method, the shape of your pile, basically. And then with that in mind, here's going to be the step-by-step of what you're going to do. For static compost, there's two options. You could say, I want to get all of my material together and mix it up and not touch it for a whole year. I think for most people that are coming to this from an urban setting with food waste, you have a little bit of food waste every week. You don't want to wait till you have a whole, pallet bay worth of food waste to deal with. You want to deal with a little bit every week. So what I would recommend is wait till you get about a bucket full of food waste. If you say that's going to be your 30% high nitrogen, then you want to get 70% worth of brown. So I would say maybe 3 buckets worth of brown material, whatever you have on hand. And one thing to note with static compost is there's no risk of using too much carbon in static compost. We don't care about getting it hot. And so using more carbon than might be ideal or more than 70% is not a problem at all. I would recommend as you're mixing the food waste into the wood chips, you really want to get the carbon, especially get it moist. The food waste is usually going to be moist when it comes out of wherever it's coming from. Wood chips can be dry, especially if they're fresh. So like a pre-soak on them can be advantageous. Mix all that stuff up, get it into your system, whether it's a pallet bay, a fence ring, whatever, and then take a look at it. You don't want to see a lot of visual food waste sticking out of the pile. So if you mix it up and you're still seeing food waste here and there, add another few inches of browns on to cap that up, just to make sure you're not losing any smells, that sort of stuff. And then it's hurry up and wait. You can do this every week, every 2 weeks, every month. You can just add more material onto the pile until it gets full up to the top of your bin. And then you say, okay, stop, make a little note. Compost filled up on May 17th or whenever it was. And you start filling up the next bay. And then in about a year, you can come back and harvest what was in the bay before. Don't be alarmed if it shrinks significantly over time. That's going to happen. Usually about, you can get it from full down to like 2/3, even a half shrinkage, depending on what materials you're using. There can be quite a lot of shrinkage. It can be kind of alarming to see. You're like, wow, this was full. And then a year later, you're like, man, this thing is smaller than I thought it would be. It's pretty magic. In terms of telling when it's done, obviously there's the wait a year. You can also kind of look at the pile throughout the year and you'll start to notice that it will change over time, but the color, the consistency, it'll start to look like compost. That's when you're kind of thinking, okay, this might be almost done. And I think that's pretty much all we need to cover on static compost here. And we'll go to, and at the end, I am going to talk about harvesting the compost and using it and then, ways to use it in the garden. So we'll circle back to that. With hot compost, again, this is the most complicated method. Here it is challenging to add a little bit every week. You kind of need to have a mass of material to start with and start it and not add new material to it if you can help it. And you do want to go heavier here on the green materials. Different green materials have dramatically different amounts of nitrogen. So if you have manure, that might be pretty heavy nitrogen, whereas if your food waste is mostly veggie scraps, that's going to be a lot lower. A rough ratio to start with is aim for 60% browns, carbons, 40% green, nitrogen. And it's a trial and error process. You're going to mix all that stuff up. I would recommend at least a pallet bay full of material for thermal mass sake. Mix it all up and you need to be able to monitor the temps. Within a few days, you should be getting up above 131. If that's not happening, you have to add more greens into the pile. And for recording temperatures, they do sell compost thermometers. A 3 foot is a good length for an at-home system. I believe you can Google around and find some ways to extend a kitchen thermometer if you want to save money, because a compost thermometer, you can spend like $150 on a compost thermometer that you may or may not use, very often. So, I'll be honest, I have one in it because I don't do hot compost that much. It just kind of sits a lot of the time. But can be a good tool to have. Anyway, so you do need to monitor your temperatures and you're just going to react based on the temperature. So if you're in the optimum range, you're going to leave it for the amount of time you need to leave it for. Once it has been that amount of time, you're going to flip the pile, monitor temperatures again. And what we're saying here is if it is too cold, you have to add in new materials. If you're adding new materials, you're adding new pathogens into the mix. So you're going to have to keep mixing it longer to make sure that you've gotten all those pathogens dealt with. That's why why this becomes so tricky, is because you need a lot of material to start and you need to get it hot and keep it hot without adding any new material in. There is a risk of it becoming too hot, although if you achieve this on a backyard scale, please reach out to me. I'd like to hear your recipe because it's hard to do. But when you have a huge pile, if you're working with your neighbors or a commercial facility, there is a risk of fire breaking out above 175 degrees, and so you do need to monitor for it being too hot as well. The way to cool it down is to turn it, mix some air in there. If it really keeps getting too hot, which again I don't think anyone here is going to encounter. You can add in more browns if you need to kind of cut some of that fuel of the nitrogen. You do need to check or be aware of moisture content, and this is probably a good time to define moisture content so it's not just vague, keep it moist. All water or all life needs water to live, and measuring moisture in these materials can be a challenge. I like to use a hand method. It doesn't work as well with wood chips or something that's very solid, but with other materials, especially like partially finished compost or some of our more broken down materials, you can take a handful, squeeze it with all of your might, and you want to see typically 1 to 3 or 4 drops of water come out. If there's no water coming out, you're on the dry side. If there's like a whole stream of water coming out, you're probably on the wet side. And remember that the water in there can displace oxygen. So we do want there to be adequate water for life, but if we have too much water, that can kind of contribute to some of those anaerobic, low oxygen conditions, bad smells. Another thing to consider with the hot compost, same as with the static compost, if you see a lot of food waste sticking out around the edges, you may want to add some browns on top to kind of cap that stuff in there. And this can complicate your mixture down the road if you add too much browns and cool the pile off too much. Just there's a lot of nuances to operating a hot compost pile. It's a very involved process, and it can be rewarding and it can be done, but it is challenging. So I hope that gives you the gist there. And again, we can come back to all this at the questions later. Worm compost is, I think, the funnest method. It makes some of the best compost for your garden in my experience. And it is easy once it's up and running. Getting it running can be a little bit tricky. This is animal husbandry. You are raising worms in addition to making compost. And so you need to really learn what makes the worms tick. Like I said, once they're up and running, their needs are very little. Getting them up and running is a more fragile process. So people in the worm world talk about their carbon. Instead, they use the word bedding. It's basically the same thing. We need a material that can stay moist, that the worms can live in. It's typically going to be any of our brown and carbon-rich materials will work for this. Aged wood chips and aged leaves, I find, are the best, but anything you have, whether it's sawdust or shredded cardboard, this can work as the bedding for the worms. And primarily, the bedding is a place for them to live in, but there is a food value in the bedding for the worms. The worms are primarily consuming bacteria, microbes, fungi, those sorts of things. And so there are microbes living on the brown material. There is enough food to sort of sustain them, but not enough to really grow their population dramatically. And so when you're starting a worm bin, you want to add just bedding. I'd say like 1 to 2 inches is pretty good. As I mentioned, it can be any sort of container, any sort of bucket, old Tupperware. I like to do it outside with my bin on the ground with holes drilled so that as it rains, water can drain out. That means my worms can also come and go as they please. If they get mad at me, they'll leave. If they're happy, they'll stay. You can set up a worm bin in your kitchen the same way. Just have a tray underneath to contain any water that leaves, and know that if you make them unhappy, they will leave into your kitchen. So be aware of that. But it can be done in the kitchen. So you're going to add your bedding into your selected container, and then you've got to source your worms. You can go out into the wild and find composting worms. Most of the composting worms you'll find are not native. A lot of them are from Asia, but they're here. If you may have noticed, if you've ever let organic material sit on the ground in your yard, there's a lot of worms in it if you go and poke through it down the road. So you can harvest your own worms if you'd like. A lot of people opt for buying in the worms because it's faster. You can get a lot of them that way. They can get shipped in the mail. It might sound crazy, but they can be shipped kind of overnight mail to you. They come in a little burlap bag. So, opening up your mailbox and there's worms is an interesting experience. You're going to add them to your bin. And again, worms really like moisture. So you want to, when you squeeze that bedding material, you want a few drops of water coming out for it to be moist enough for them. And when they arrive, they're going to be kind of stressed out from travel. You want to put them into the bedding, let them sit for a few days. They don't like light. So either keep them somewhere dark, or I do this outside. So I do it in a shady area under a tree, but I will sometimes put burlap or cardboard over top of the bin to kind of keep it nice and shady and cool for them in there. And the worms will start to get acclimated to the bedding. After a few days, you're going to put some food in there for the worms. They can eat a wide variety of foods, but they really don't like the animal products that much. They can handle manure, but they don't like animal fats like bones. That, you know, if you have a cheeseburger, that's not really their favorite food. Really, plant-based waste is what they prefer to be eating. People that do worm breeding, some of their top foods, they will cook tubers and fruit and then puree them up in a blender and use that to feed their worms. But you could use any veggie scraps or leftover scraps coming out of your household, or if you have a source of manure, like I said, they'll eat the manure. You want to start off with a very small amount of food waste for the worms. And that's one of the challenging parts is at the beginning, you're going to probably have way more food waste than your worms can handle alone. You're going to give them maybe a small handful to start, and you're going to check every few days. Are the worms hanging out around this food? That's what you want to see. Are they eating the food? Sometimes it might take 1 to 2 weeks for them to eat a small amount of food at the beginning. But they can double their population every 60 to 90 days. So depending on how many you start with, you can quickly get to a point where you have a silly number of worms in there, and they can actually handle a lot of waste once you get that population built up. And I recommend to people in a small bin setting like that, feed them in the same spot, or at least the same, divide the container in half, feed them mostly over in one half until you get a large buildup of material. Kind of you'll see as you feed, the material starts coming up and up and up in the bin. And every time you add food, you can add some bedding to help kind of cover it up. We do want to prevent other organisms from getting into the pile. If you're doing this outside, other bugs are going to get in. That's okay. You just don't want any one specific other bug to take over. You wouldn't want to see like the whole bin covered in fly larvae. One of the ways you prevent that is just by capping that smell a little bit. The worms are already there. They're going to find the stuff. If you put some bedding, cover the food thoroughly, it'll kind of slow down the you're not putting out the bat symbol to all the other bugs in the area. And you're just going to be feeding them as they run out of food. So like I said, it might start every few weeks, then it might start to be every week, then it might be every few days. And once your bin is starting to get full, you can switch. Now I'm going to start feeding them on this other side. The worms are going to kind of primarily migrate over where the food is, and you can start harvesting the material where you had previously been feeding them. If you have multiple bins, which is what I do, I get the one bin pretty full of stuff and worms, and then I'll get another bin and throw it on top with more bedding and food. Once that top bin starts to get full, I'll take the bottom bin out and I'll harvest the entire contents of the bottom bin. The worms, like I said, they're mostly going to hang out where the food is. And so if you're feeding from the top, you can easily harvest everything from the bottom and use it. With worms, it's really important not to overfeed them. It's not that overfeeding them hurts them. They're not going to overeat and get fat. The issue is more that other organisms are going to smell that stuff and come in and take over your pile. And you can get smells, you can get gnats and flies and things that, again, they're not necessarily causing harm, but they're not really helping you. And they can be annoying to deal with, especially, if it's right outside your back door or, if you're in your kitchen, especially, you don't want fruit flies and all that sort of stuff. So I think that's everything we want to cover on worm compost. Again, if you guys have questions at the end, I'm happy to kind of field and go into greater detail on worm compost. I want to cover some of this we've covered already, but I want to go over just some general tips for success. Thoroughly mixing is really important. What you want to avoid is a situation where you have a big chunk of high nitrogen material somewhere that's not mixed with other stuff. You can create little pockets of anaerobic low oxygen activity. This can lead to smell. So mixing is really important, and really mixing is another opportunity to be checking that your moisture is adequate. We talked a little bit about covering the compost pile. If you see food waste, we typically call this in the industry a carbon cap, capping the pile with carbon. Again, it's just always a good practice to have a little extra carbon material on the top to kind of capture some of that gas and that smell and keep it on there. You're going to have to just trial and error and learn how do your inputs behave. And something you're going to notice if you keep doing this over time, you might have the same inputs, but as the time of year changes, things behave differently. When it's colder outside, all of a sudden decomposition slows down. We're in a pretty temperate climate here in Virginia, so there is some level of activity happening in the compost pile almost year round. My piles, even my smaller piles, when it snowed this winter, I would go out in the morning. There's no snow on the top of the pile and there's steam coming up. But I can tell you just from digging around periodically in the piles, decomposition is significantly slowed. Material that would have broken down in like a month or two of summertime I might still be able to find that material in the pile after like 4 months of winter, decomposition. So you're going to have to learn your materials and your climate. It's going to be a process of trial and error. A lot of people ask about pests like rats and raccoons and possums and bears, and it's certainly important to consider these critters. My take is that I have never seen rats or rodents become a huge concern in my compost bins, but I live in a rural area where there's lots of predators for those sorts of rodents. In an urban setting, you might have a different experience. Rodents are challenging to exclude from any sort of situation. They're small, they're smarter than you'd think, and they can get in. So if you have issues with rodents, I don't have a ton of advice other than to say I haven't seen it. I don't think you'll have a huge problem. What you do really want to think about, because the major problem with rodents is just that they'll be there. They're typically not going to make a huge mess, but you don't want to be feeding them and contributing to their population growth in an urban area. The bigger pests, and I use pests, lightly. I mean, I love all these animals, but they can be problematic. Raccoons and possums and bears, if they smell something they want in your pile, they're going to go tear it up to get it. And you might have a pile, you put in all this work, it looks really nice, you had a carbon cap, you felt good, you went to bed, and you wake up in the morning, you're on your way to work, you walk out to your car, and there's a huge hole in your compost bin, and there's banana peels and eggshells and stuff all over your yard because a possum got in there, a raccoon or whatever. They are easier to exclude. You can use fencing, hardware cloth, welded wire, pallets. If you have issues with critters getting in, you can exclude them. Basically just a physical barrier. I would also add that it goes a long way. Your carbon cap is going to limit smells. Their sense of smell is much stronger than ours, but still capping that material with a heavy load of carbon will prevent a lot of the smells from getting into their nose. So I use a pretty heavy carbon cap. We have a lot of bears around, and I am very interested in not letting the bears come near where I'm at. We've got chickens and fruit trees, and I would like them to not find us. So we've had good luck so far, but it's important to be thinking about this sort of stuff. Trying to think if there's anything else with pests. I will note that, and I should have or could have covered this when we talked about shaping your pile. I like pallets and fencing because they allow air to come through. I have seen some people that make, bays for their compost out of cinder blocks and this sort of thing, and that does a really good job at containing the pile, but it also slows oxygen infiltration into it. So just while we're talking about fencing and exclusion, I like more permeable barriers for critters because of the air content. We've talked about bad smells. If you get a bad smell, you probably got a problem going on. Don't freak out. It's a trial and error thing. Add more carbon, cap it up. It'll go away. I would say don't beat yourself up too much. We all do things that are bad for the environment. No one can be perfect. We all drive cars, I'm assuming, in this room, or take public transportation. And so if your pile smells and you're releasing some greenhouse gas, it's not ideal, but you can learn to fix it, and it's part of the process. It's really unavoidable in the learning process, I would say. So don't beat yourself up too much. And again, remember, this consistent moisture thing is important. Anytime I get kind of lazy about this, but check your moisture, pretty regularly. It's going to help speed up the decomposition of your compost and improve the quality of it. At all stages, it's always good to be going in there, getting a handful of material, wear gloves if you want to, and just kind of keep an eye on what the moisture is. Because if it gets too dry, things really slow down. I had an experience just last week of digging around in the compost. I haven't checked on this one pile in a long time, and I figured it'd be moved for a little further along, and it was bone dry in the top, 1.5 feet. And I was like, well, I guess I could have been watering this, more frequently. So it is always good to be checking on your moisture. I do want to briefly touch on busting up myths. I'm going to check the time here real quick, see where we're at. Yeah, because I want to get to your questions here. We talked about meat, bones, eggshells, citrus, dairy. All of these things can be composted. You just need to know how they behave. Eggshells and bones are going to take longer to break down. Having a lot of heat in your pile also speeds up the breakdown of these materials like bones or big chunks of wood, eggshells. I would say if you get to a point where you have finished compost and there's some eggshells in it and some bones, don't worry about it. You can put that in the garden. It'll keep breaking down. The plants will access them. If you don't want to put it in your garden, just cycle it back into the next compost pile It will eventually break down. I know my granddad's always getting frustrated about the eggshells in his compost, and I'm always telling him like just put them back in. They'll go away eventually. It's not they don't break down as fast as some of the other stuff. It's not a big deal. People get really worried about the smell of meat rotting, that's going to attract pests, like we just talked about. I have found that fruit is much more attractive to all of the critters that we don't want. So meat might be really smelly to us. And yes, some critters will eat it, but rotting fruit is like I mean, if you want to get pests in your yard, put some rotting fruit on the ground. You will see all of the wildlife will come out. So again, cap that with carbon. That is your and you can compost dairy. I don't know why people are so afraid of dairy and citrus. It's not good in worm systems, but that dairy and citrus breaks down no problem in any other sort of composting pile. I do want to touch briefly on compostable plastics. The main point here is that some compostable plastic products do decompose, some of them do not. This is kind of a rapidly changing industry. If you're going to use compostable plastics, I would recommend finding a reliable certification. BPI certification is kind of widely accepted in the industry. And also know that even some of these certified products, they can behave like bones and eggshells where they take a long time or a lot of heat to really thoroughly break down. So they can be challenging in backyard systems. So you do need to be careful, but there are products out there that will work. When you're using your compost, or if you're buying in you might use some of yours and see a good plant response. You haven't made a lot. You want to buy some more. It's important to note that not all compost is created equal. The best compost that I've ever worked with, it tends to be more of a chocolate brown color than it does like black. You can buy a lot of commercial compost that's black. Usually the better stuff, in my experience, is more brown. Good compost is going to have a really good smell. It's going to smell kind of like the forest floor, kind of earthy, healthy smell. If you go and smell compost, like you can get municipal quality compost that's jet black and you smell it and it smells kind of bad sometimes, it's not quite finished breaking down. It's better than nothing, but just there's a range of quality in composting products. And when you use them, be aware that you are adding some fertility in the form of soluble nutrients, just the same as fertilizer. There's soluble nutrients in there that roots can soak up. But there's also the inoculation potential, the biological content of compost. Compost is really good at growing lots of microbes. A lot of our soils are pretty depleted from microbes. And so one of the big benefits of compost is that you are inoculating your soil with beneficial biology. You also are adding organic matter, like we talked about at the beginning. This really adds that porosity and ability to hold water. I like to just top dress compost. It's very simple. I would say anywhere from half an inch to an inch is a good amount to top dress. Put some mulch down when you're done top dressing it. I don't like to have bare soil, and I also don't like to have bare finished compost exposed. The rain can compact it, the sun can dry it out. So I'd recommend mulching after you top dress. You can till it into the soil. If you like to do a lot of tillage in your garden, that's also totally fine. Add it to potting medium. If you have a small amount of compost, you want to stretch it really far, you can make a very simple compost liquid extraction. You're just going to get a bucket of water, throw a few handfuls of compost in, mix it up with a stick, use that to water some of your plants. You can basically take a small amount of compost and spread it out further. You're going to have less of a plant response than if you had did a big top dress around each plant. But if you're low on material, that can help. That's different from compost tea, which I would recommend against because that is a more complicated process where you're going to brew or aerate that liquid for 24, 48 hours and add in all sorts of sugars and food to kind of expand the microbial populations. That's a complicated process that if you really are passionate and you want to do it, you certainly can, but it kind of goes beyond the scope of what we can talk about in this talk today. I do want to make people aware of black soldier fly larvae. They are a little bit, some people are more grossed out by them. They're not as friendly looking as worms. They're basically maggots, but they are a native insect. They don't really make good compost. They make very little poop or insect frass. They mostly turn stuff into bug meat. They make a lot of bugs, and they're good for feeding chickens and reptiles and fish. The main benefit to black soldier fly larvae, although they're only active in the summertime, so you can't do this year round, they process food waste faster than anything I've ever seen. I mean, the amount of food waste that they can eat in like a couple days is mind-boggling. So if you have a lot of food waste and you want to deal with it, black soldier fly larvae can be fun. Feel free to shoot me an email if you've got more questions on that. And we did talk a little bit about anaerobic digestion, so I think we can kind of dismiss this. This is our last slide here. We can cut to questions. I think it's all pretty much explained there. So I guess, Ann, you're going to be monitoring questions from the chat, but otherwise, if you have a question, feel free to just stick your hand up and we can deal with it like that. Yeah. Sure. Yeah. So a couple things. I do have a few little handouts over here that you can read that have some more information. I've also got a piece of paper you can leave your email and we can send you more information. I've got little business cards up here with my information. But to talk about the service, we have not started yet, but we are anticipating starting in June. We're still kind of basically generating interest within the community. And we'll be coming around. We have different offerings once a week or once every 2 weeks. We will come and collect your food waste from your home. We'll provide you a bucket and make sure it's clean every week, the same as your trash or recycling service. And we'll take your food waste to Roanoke. There's a certified facility called Star City Compost. They'll compost it and get that compost back onto local farms. So yeah, it's like a monthly subscription service, the same as your trash or recycling. Sure. Yeah. Right. Yeah, I would say there's oh yeah, yeah. So the question was in terms of carbon sources, I like wood chips a lot, but are there any other things to avoid with carbon sources or things to be aware of? And that's an excellent question. One thing to be aware of if you're going to go with straw or hay, a lot of farmers nowadays are using persistent herbicides, and persistent meaning they don't break down very readily in the soil. If you get hay that was treated with one of these herbicides, it can be deceiving because the compost will still break down, but if you try to grow plants in it down the road, the plants might die. And so if you're getting straw or hay, first of all, ask the farmer. Usually farmers are pretty honest people. They don't want to mislead you for the most part. But you can protect your plants by doing a test. Take some of your compost and you're just going to evaluate what's the plant response. If I take some compost, put it in a little tray, put some seeds down. People like to say do some grass seeds and some legumes to try to test a few different types of plants because some of these herbicides are, kind of more specific on certain types of plants. If you get the seeds germinate and they're nice and green and growing, you're good. If you see a lot of yellow and pale, sickly growth, that could be a persistent herbicide issue. It could also be other things like your compost is not finished breaking down thoroughly enough. But that's the best way to protect your plants from that is to do a test. Other things to be aware of, I don't get too worried about the pH of specific carbon sources, but I do like to think about structure. So if you're going to use, say, like pine needles or sawdust or bark-based products, especially the sawdust and the bark-based products, they don't provide a lot of structure. The sawdust compacts really easily. And bark, if you think about it, is intended to keep things out of the tree and keep things in the tree. So it can do the same in compost. It can become somewhat hydrophobic. All of this changes as it breaks down. It gains that pore structure, but during that initial period, you can have issues with water retention and that sort of stuff. Pine needles also, they are very good to add. It might be challenging if pine needles was your only source of carbon. I always like to I love wood chips, but I do try to diversify. The more diversity of inputs you have, typically the better, the more diverse microbes you'll get and the better pile you get. So that's an excellent question. I hope that answered most. I'll go here and
Two questions. Well, statement. Confirm about lid, shut or no lid.
I don't like to put a lid on it because it can slow down oxygen coming in. But if you did want to put a lid on it, say to keep critters out, or maybe even just to keep like your cats from sitting on top of it or something like that, you can just drill holes in the lid. That way air can still get in but it's contained. Yeah, so that's totally fine. Yep. Yep. That tends to be the problem with wood chips. You either have absolutely none or you have way more than you ever are going to know what to do with. It's very rare that you're right in the middle on the wood chips. But I saw a question, yeah, in the back here. Yeah, I get questions about this a lot, especially through my. Yeah, yeah. Oh, yes. Good question there. Yeah. Do I get concerned about black walnut wood chips or leaves or any sort of carbon products coming out of black walnut? The concern there is that black walnut trees can produce a compound called jungalone that can prohibit the growth of other plants. There's actually a lot of plants that do this that people are not aware of. Sunflowers do this. A whole range of plants have the ability to produce compounds that can slow down other plants around them. Walnuts, for whatever reason, have gotten really popular for this. Although in nature, I almost never see the black walnuts actually killing other plants. It's somewhat rare. So all this to say, it is important to be aware of. It is certainly a thing that can be observed. Walnuts producing this jungalone compound, but jungalone breaks down pretty readily in soil and compost. And so if we're using walnut-based wood chips, that stuff is going to break down before the compost is finished. And by the time you put that compost onto plants, that jungalone is long gone. If you had fresh walnut wood chips, it might not be the best idea to maybe mulch around some plants right after the tree is chipped, maybe wait 6 months or so. But for using in compost, it's totally fine, fresh or aged. I would add that with wood chips and with a lot of our carbon sources, if they're just slightly aged, like 3 to 6 months, that really increases their water retention ability and it makes them better at absorbing smells. So as you're kind of sourcing carbon, don't be afraid to stash a little bit. Obviously you can't have too much, like you're saying, you might kill your whole yard with a massive pile. But if you can stash some and let it sit, so you always have some ready that's slightly aged, that can be a benefit. Yeah. Over here. Yeah, that's a good question. The question is, how does biochar fit in with this? Biochar is an excellent resource. It very similar to charcoal. It is material that my understanding is burned in the absence of oxygen, and it creates this really there's a just incredible pore structure within the char, and it can really improve. It's kind of like organic matter. It can dramatically improve soil's ability to absorb and retain water. Another thing that's sometimes when I say that in groups around here, we have a lot of clay, and people are, I don't really want my soil to retain more water. But adding that porosity actually helps the clay drain better, and it helps oxygen infiltrate better into the clay. So I would say biochar is not necessary, but it certainly is great to have it. And a lot of people talk about quote unquote activating biochar. If you make it, there's not a lot of microbes in it when it first comes out of the fire. And so people have come up with all these ways to get microbes into the biochar that they really like to live in that pore structure. I would say if you have biochar, if you're interested in biochar, mix it into your compost when you're making it. And then that way you just apply it to the soil. It'll be totally inoculated at that point. And so I think it's certainly it's a good thing to explore. Yeah. Yeah. Yeah, and you can consider it a carbon source, and I wouldn't try to go crazy. I mean, I wouldn't try to make a pile where biochar is my only carbon source. But if you've got brush that you're making into biochar, and yeah, you've got just count it in your recipe as a carbon source and mix it in thoroughly. And I think that's we've done some of that on the farm, and it's worked pretty good. You can still see some of it in the compost at the end process. You can see some a little black, and you're like, okay, hopefully it's just going to be filled with microbes and add some, porosity and all that. Yeah. Yeah. Are there any other? Yeah. Yeah. That's a good. So the question was, what kind of paper products are good for using in your compost? First, you want to avoid, especially if you're dealing with cardboard products, no glue, no tape, and paper products are a little bit complicated. It's hard to know usually what was the source of this paper, what sort of additives went into it, what about the ink that's on it. If you can verify that you don't have any toxic chemicals in your paper, and you can really what you want to do is have a shredder and shred it up. That'll really facilitate it breaking down. Because if you have a bunch of sheets of paper, you can imagine they get kind of compacted. It can be hard for oxygen to get in. But the paper products are compostable. So what I typically do is if I have really clean paper that I know where it came from, it doesn't have a lot on it, I might save that and shred it. If I get really clean, like a huge box, it just has a little bit of tape on it, I might pull the tape off and use that. Corrugated, yeah. But I primarily, unless I'm really short on carbon, I tend to prefer to recycle my cardboard and paper products because there are viable ways for it to be recycled as well. A lot of these other materials, there's not a big recycling option other than composting. But if you have clean, like I said, it just can be hard to verify. How do you verify? Like, is there anything toxic in the ink or in the glue or the paper itself? Definitely nothing that you don't want. You want to avoid glossy matte type finishes. That sort of stuff. I hope that kind of answers the question. It's a little bit challenging to figure out. Yep, another. Hmm? Big. Yeah, yeah, yeah. That's a good question. So the question was about tumblers. If you've seen those little things in your backyard, they're usually black plastic. You put the stuff in and you tumble and it mixes them. One way to use it is just as a mixer to mix your material before you put it into a pile. Some people will leave the material in there. I would look at it as a hybrid between hot compost and static compost. So like you're probably not going to get the heat that you need to kill the pathogens, but you are going to get some heat. And that is going to help speed up the process of the breakdown. And it's also just an easy way to mix stuff. And so you can mix it up in there. You can put it directly on your pile if you want, or you can let it sit in there for a while till it gets full. But I would still take that material and leave it in a static setting, probably for at least 6 months, just to let it keep breaking down. So you can see it as a hybrid hot compost thing, because you are going to generate heat usually that way, but probably not enough heat to kill all the pathogens entirely. Yep. Mhm. I like to compost in the shade actually because it slows down the rate of water loss. But if you're trying to get heat, like if you really are going for that hot compost, then the sun will help, especially in the winter months, being out of the shady areas. So it just kind of depends on your goals and what you're trying to. Yeah. Yeah, you see the steam rising off it, and it gets, yeah, yeah. Good, good. Oh yeah. They can.
Okay, we're doing something a little differently with our speaker kit. You may have heard last month we had it's kind of like at the dentist, you get to pick a little prize. We have some sustainability
Sweet.
things in here. So books, some of our upcycled tote bags, reusable straws, different things. So you can pick
Okay, sweet.
your kit.
Thank you.
If you're around here.
Yeah, I'll be around, and like I said, my contact info is here. So I'm always happy to talk. Shoot me an email, and we can keep the conversation rolling.
So, come back next month and you.
Out of the emergency, if anyone is good at when we. I had one that took a dive.
Mm.
Oh, you can.
And July coming up. So, we all going to work together and easily walkable bicycle, right? So we'll be sending out. All right, thanks everybody.
Thank you.
Presentation.
Yeah, absolutely. Sure, sure. Yeah, yeah. We wouldn't have to give the whole thing. Let me just make sure I'm muted here.